Characteristics of solid-state drives. This presentation aims to provide a basic understanding of 5 main characteristics of SSDs: terabytes written, TBW, write amplification index, WAI, drive writes per day, DWPD, wear leveling, and read disturbance. These characteristics are important factors that determine the lifespan and performance of SSDs. The TBW, or terabytes written, calculates the expected capacity that can be written on an SSD's entire lifespan. 3 factors affect the TBW: the user capacity of the disk, flash endurance, which can differ depending on whether it is SLC, ISLC, or MLC, and WAI, write amplification index. Now let's understand what WAI is and how it is calculated. WAI is the ratio between data written to flash and data written by host. For example, the host would like to write 4K byte to the flash, but in reality, the flash moves 8K bytes because of wear leveling, garbage collection, and other factors. Then the WAI is 2. So why is there such a difference between the actual data written and the capacity originally commanded by the host? What will affect WAI value? Basically, there are 2 types of factors that affect it. Differences in controller type, firmware structure, and flash configurations are factors that make up the quality of an SSD and cannot be changed after it is produced. The other factor is the testing environment, including the type of test tool, data format or workload standard, and the health status of an SSD. There are 3 criteria in the workload. It could be sequential, JEDEC 219 client, or enterprise. As to the health of the SSD, it refers to the amount of early bad block and erase counts it has at the test period. This is the JEDEC 219 Enterprise Workload Standard. It clearly defines the data format and assigns a specific percentage to each workload, so each user can clearly set the test benchmark. On the other hand, JEDEC 219's client workload is not very clear. It only defines a random data pattern. As to the degree of randomness, it is subjectively defined by each SSD vendor. Here I'd like to show how InnoDisk tests the WAI. We use the U-Link test tool and its data script to test WAI under client and enterprise workload standards. We believe the U-Link tool provides an accurate test standard since they are a SATA association member. For the sequential test, we use I/O meter to run a 100% sequential test with 64K byte data. Results derived from the U-Link and I/O meter will be separately detailed in all our technical documents. You will easily find a description of the test conditions at which we received the results. DWPD, drive writes per day. It describes how many bytes of data the SSD is rated to accept before reaching wear out. It is important to note that this includes consideration for the extra writes imposed by WA, as well as user data, but that it is independent of the physical capacity of the drive. Simply put, it is just the TBW value divided by days per life. Wear leveling is an algorithm used to avoid data to always be written onto the same block. The algorithm will compare the erase count of each block and will write onto the block with fewer erase counts. There are 3 kinds of wear leveling: dynamic, static, and global wear leveling. The dynamic type only compares dynamic data with unused blocks. The static type compares all blocks in the memory unit, and the global wear leveling compares all blocks in a device. Therefore, this type of wear leveling most effectively helps prolong the life expectancy of a disk. Lastly, read disturb refers to the data error through read operation. When a bit is read, there is a chance the nearby bits will change the state and become an error bit. The more times the bit is read, the greater the probability that read disturb will occur. So, how is read disturb avoided? The read count of every block is recorded so that when it reaches the threshold, it will move the data to another block and erase the old block. Thank you.